So, okay, I'm gonna try something different today. So, gonna have this little guy over here. What we're gonna do, number 6, is, now we did 1 through 5 on Friday. So here we're gonna find the linear approximation to g of x, and it equals the cube root of x at x equals 8. Okay, so we're gonna just go ahead and do that. We wanna make sure that we've got that equation first before we start thinking about approximating values for cube root of 10 and cube root of 16, and then we're going to go ahead and find the error for those. Okay, so let's go ahead and do g of x equals, we're going to rewrite this now as, now remember, we want the point and the slope. So I'm going to rewrite this as x to the 1/3, okay? And I'm going to go ahead and find the slope first. So g prime of x equals 1/3 x, and then that's going to drop a degree, so that would be 3/3, negative 2/3. Okay. All right, so what is that? Then what we want to do is we want to find, what is that? I just asked a question. What is that? That is the equation for the slope. I want to know when it happens at 8. So let's go ahead and actually plug in an 8 there. So 1/3, 8 to the negative 2/3 will give me my slope. All right, so let's see. 8, cubed root of 8 is 2, okay? And then 2 to the second power is 4. But it's a negative exponent, so that's 1/4. 1/4 times 1/3 is 1/12. All right, so that's my slope. And now for the line, I'm going to go ahead and go L of x. Now L of x equals this, all right? That's not an approximation. In fact, what it is, what we're saying is that g of x approximates this line, okay, around that moment, okay, or I should say the neighborhood. That's the word that they like to use, they. All right, so we've got 1/12, and then we've got the point is x equals 8, but then when you plug in an 8, what's the output into the original? That would be the cube root, so that would be 2. Okay, so plus 2. All right, so that's our ln of x. All right, it's a little hot in here. All right. So we got our guy. All right, so now what we want to do then is we're essentially just going to find out what L of 10 is, right? Because this is the approximation. So because we're in this little ballpark, I'm going to go ahead and I don't have my calculator next to me, so I'm going to have to do this the long way. 2, that's 1/6. 1/6 plus 2 is 2 1/6. So 2 1/6, which is basically the same thing as saying 13/6. All right, and then we're going to go ahead and find the approximation for the L of 16. So 1/12, that'd be 16 minus 8, and we'll calculate the error over on this other side. Okay. All right, so then we've got plus 2. I did it at 2, right? Yeah. Then it's 8/12. That's going to be 2/3, and that's 2 2/3, which is the same as saying that's 6. That's 8/3. Okay. All right. So let's go ahead and find that error now. So the error is when you take the actual and you subtract the estimated one. Okay. So let's do for the 10. All right, error, or we'll just say like, do we want to say E of X? No, we'll just call it error. Yeah, we could have gone E of 10, but that's okay. Error equals the absolute value of the actual value. Okay, so what is the cube root of 10? Now this I actually do have to get a calculator. All right, so the cube root of 10. Actually, the cube root is in math. You got to go to math and then go down to 4. All right, and that is 2.154434. We'll go to 5 minus. And honestly, you can just leave this in your calculator. There's just not enough room to write it down. And then we said that this was 13 over 6. Okay, so let's do 13 over 6 decimal. And then what we'll do is we will take this guy minus this guy. All right, and we'll take the absolute value. So that is 0.01223197. Okay, that's fine. So what we want to say then is that the error is, let's put absolute value actually there. The error is, we said less than 10 to the negative 1, right? Just because of that 1, 0. So this is a fancy way of saying that. I like this. This is really nice. And then for x equals 16, you're going to have the error. We'll just keep it in our calculator this time. And we're going to say that the error is, let's write this a different way. Let's say that this is the absolute difference between g of x minus L of x. Okay, that's really good too. And then what we'll do is we'll say for 16, the error, okay, is 16 minus L of 16. Okay, so this is just a really nice compact way of saying that that is the formula. And so let's find out what the cube root of 16 is. Okay, we got that. Then we're going to go ahead and grab this 8 over 3. All right, so what we're going to go ahead and do is subtract the actual minus this guy. Okay, and now we got negative, but we're taking the absolute value, so we got 0.146824, 567. Okay, but what we want to say is the error is less than 10 to the 0, because there is no 0 there. All right, so pretty cool. And I hope you kind of can visualize actually what would be happening in the graph with something like that. So let's do this guy. You know what? Why don't we? I'm going to skip this one just because I want to do that in person. Let's go to number 8. Okay, so let's skip that to 8. These are the kind of ones that I think are kind of simpler enough where I just they might not require any questions from you guys. Okay, but we're going to wait on the table. And where are we at? 7 minutes? Okay. So find the linear approximation for this guy. Okay, so he is 1 over x minus 1 at negative 1. So we want to find an approximation at negative 1 plus 2. Okay. So imagine this though. This is pretty cool because this, you can do this stuff without a calculator, you know, because you can get the linear approximation and you can do that without a calculator if you know calculus. So let's go ahead and find that. Let's rewrite f of x, and we need the derivative and we need the point. All right, the point I can see is negative 1/2, but I'll do that. That's just mentally. Let's see if I can get this. There. Okay, so we rewrite it like that so that when we take the derivative, that's a lot easier to do. I can just use the negative in front. The derivative of the inside is just going to be 1, so therefore the chain rule just really doesn't apply, but he will drop a degree. Okay, now that's not going to mean too much when you get, yeah it does actually, because that's negative 1, not positive 1. All right, so let's see, we got, we're going to plug in the point of interest. That's negative 1, so let's just plug it in, negative 1 minus 1. Okay, lots of negatives here, be careful. It's going to be negative 2. Negative 2 to the second power is 4, but negative 1/4, but then the negative on the outside makes it negative 1/4. All right, so lots of negatives there. Negative 1/4, so now L of x equals, so notice that I'm not even touching this guy. I don't care right now. I'm just establishing the line that is very close to x equals negative 1. And what I want to do is I want to get the point. Okay, so I know that negative 1 is the x value, but when I plug it in, I get 1 over negative 1 minus 1, that's negative 2, so that would be negative 1/2. Okay, so that's my point. I got my slope, got my point, I'm all set. So slope is negative 1/4, and x plus 1, because we changed the sign on the inside of the parentheses, and then we do minus 1/2. Okay, we don't change the sign out on the outside. You already know that. So now we're going to go ahead and do this for negative 1.2. Let's find out what that is. Here it says calculate the error. We'll do that in a second. So negative 1. Okay. All right, it looks like that goes to 0. Why did I plug in a 1 again? No, I want 1.2. Okay. I know that it's negative 1/2. In fact, if I plugged in a negative 1, I would just get that because that's what the line does. Okay, let's do this. Negative 1.2. Okay, that's better. So let's plug in a negative 1.2. 1/4, 1, negative 1.2, that is a negative 2.2. Okay, now that I just don't trust myself. Negative 2.2 times negative 0.25 minus 1.5 is 0.05. All right, and did you guys... Oh, that's a +1. Let's try that again. Oh, you guys are probably screaming at the video. You're like, no, don't do it. Why is this? It's still wrong. Okay, let's try this again. How would you +1? Should be just 0.2, right? Still screaming. What? I didn't do 0.5. Okay. And I can't cut this video either. Shoot. All right. Negative 1.25 times negative 0.2. Enter. Minus 0.5. There. Okay. So it equals negative 0.45. Holy smokes. Oh, you guys can't even see my calculator and the struggles that I was just doing. Okay. All right, let's keep this there. All right, so anyways, I did a lot of dumb stuff on my calculator. All right, that took way too long. All right, so now I got this guy, and we are ready then to calculate the error. All right, now the error equals the actual f of, we're going to go ahead and just put in negative 1.2 minus the L of negative 1.2. And now we'll just have to calculate, well, we already know that. It's negative, nope, we don't know negative 1.2. Okay, so let's figure out what that guy is. Try to get the glare off. 1 divided by, actually, let's do the fraction bar. I like that. Negative 1.2 minus 1. Enter. Okay, so we got this guy repeating. All right, we'll make sure we get that absolute value. All right, so we're just going to keep him there, and then we're going to subtract the negative 0.45. All right, so look at how close they are. They're very, very close. And we got negative, but we're going to do the absolute value, so that would be 0.0045 repeating. And so now we've got the error being less than 10 to the negative 2. Okay. All right. We're going to stop there. That should be good. What is it? We're at almost the 15-minute mark, and that should kind of make, I'm going to go ahead and put some problems. I'll look through and tell you what problems I'd like you to do, but that's going to be kind of the drill for the rest of the hour. All right. All right, everybody. Have a good day.